Hello, everyone. Welcome. Thanks for joining us today. We're excited to share this presentation with you. We have James and Adam here from Clark Dietrich, and then we have myself from Acelab. I will quickly show everyone where you can learn more about Clark Dietrich on Acelab. So let me share my screen while we're letting everyone trickle in. All right, so here we are in Acelab. Anytime you want to search for anything in particular, you can use the search bar at the top of the screen. So here we are on their page. We've got some basic information. We've got some contact information, as well as many of their products for you to explore. So at any point in time, you can jump onto their page. I'll share a link with you all and click into any of these products here to learn more about them. You can also save them to your firm library for future reference. So definitely check this out when you get a moment. There's some really great information here for you to explore. So like I said, I'll drop the link in the chat. But before we officially get started, I want to go over a couple housekeeping items. So we will be doing Q&A today. So if at any point during the presentation you have a specific question, you can drop that in the Q&A box. You'll see a button at the bottom of your screen. You can drop any questions there. And we will also be doing a poll. So for that poll, you'll see that pop up during the presentation. It is an optional poll, so you don't have to fill it out if you're not interested in getting any follow-up information. But if you are interested in getting in touch with James and his team after today's webinar, fill out that poll with any specific interest you have, and we will get an email sent to you within like a day or two after the webinar. You'll see that come in your inbox. It'll be coming from a no reply email address at Acelab. You can respond still directly to the email if you'd like to do that, or you can log into your Acelab account and respond there. But that's definitely a great way to connect with James and his team after today. So look out for that email. We will also have a post-webinar survey. So any feedback that you have, we're welcome to it. So feel free to drop that there in the post-webinar survey. And last but not least, this is an AIA-approved presentation. So we collected your AIA numbers upon registration. So you're probably already set, but if you're concerned that we didn't get your AIA number, I'm also going to drop a form in the chat as well. So you can click that and fill it out to make sure you get credit for today. All right, that's everything on my end. So I'll go ahead and pass it over to you, James.
Thank you, Kayla. So good afternoon or good morning to everyone, depending on where you're joining from. On behalf of Clark Dietrich and Acelab, I want to extend a warm welcome. Today's session is Achieving Low Embodied Carbon with Cold Form Steel Framing Systems. My name is James Sforza. I'll be your host, and I'll be walking you through the core principles and advantages of this forward-thinking approach to sustainable steel framing. You'll find my contact details listed at the bottom of the slide. Before we start, I also want to mention my colleague, Adam Shoemaker, who is here with us today. He will be monitoring the Q&A and the chat boxes for this presentation. So if you have questions you would like to ask during the presentation, feel free to drop them in the Q&A box, and Adam will respond in turn if possible. And then whatever he does not get to, or we feel might be better for the live Q&A at the end, we'll get to in the discussion post-presentation. Okay, so before we dive into the main content, I just need to briefly cover a few housekeeping items. Clark Dietrich is a registered provider with the American Institute of Architects Continuing Education Systems. Credit earned on completion of this program will be reported to CES records for AIA members. Certificates of completion for non-AIA members available upon request. This program is registered with the AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA or Clark-Dietrich of any material or of construction or any method or manner of handling, using, distributing, or dealing in any material or product. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. And a friendly reminder that this presentation is copyrighted by Clark-Dietrich, and reproduction, distribution, and use of the presentation without written permission from the speaker is prohibited. All right, let's begin by reviewing our learning objectives for today's session. So by the end of this presentation, you'll be able to confidently explain how cold form steel framing can help you achieve LEED certification and meet those important government specifications for low embodied carbon steel. Second, you'll be able to develop a sound understanding of embodied carbon and why it's such a critical consideration in today's world of sustainable construction. Third, you'll be able to clearly distinguish between the two primary steel production methods, electric arc furnace and basic oxygen furnace steel production, and you'll be able to understand their distinct environmental impacts. And last but not least, you'll be able to effectively describe how specifying low embodied carbon steel and EQ studs can lead to substantial reductions in the embodied carbon of your cold form steel framing products. Let's jump into our first of 4 learning objectives. We'll take a closer look at how cold form steel framing can serve as a valuable strategy for achieving LEED certification and aligning with government requirements for low embodied carbon steel. Before we dive into the details of LEED and government specifications, let's take a moment to align on what we mean by sustainability. I know it's a term that we hear frequently, but it can carry different meanings depending on the context. On this slide, you'll see several definitions and frameworks, all of which are relevant. And at its heart, sustainability is about balancing 3 key pillars: environmental, social, and economic considerations. This concept is often illustrated by the triple bottom line, also known as the 3 Ps: planet, people, and prosperity. Planet emphasizes reducing environmental impact and conserving natural resources for future generations. People highlights the importance of supporting individuals, communities, and societal well-being. And prosperity addresses the need for long-term economic health and viability. When we talk about sustainable building, we're looking at more than just environmental performance. We're also accounting for the social and economic impacts of a structure across its full life cycle. For this presentation, we'll be focusing on the planet or environmental aspect of sustainability, exploring how cold form steel framing products and practices can contribute to a more environmentally sound built structure. So we're headed down the right path, but at this point, we usually get a few more questions. That sounds great, but in theory, but how do we actually measure our impact on the planet side of sustainability? In other words, what concrete metrics or indicators can we rely on to track real progress toward a more environmentally responsible built environment? The answer is pretty straightforward. We recommend using LEED as the foundation for measuring environmental sustainability, leveraging its widespread adoption and credibility across the construction industry. LEED takes the broad concept of sustainability and breaks it down into actionable, measurable criteria for each building component. It's a system that many of us are already familiar with, and importantly, many of the same experts who contributed to shaping LEED also influence the development of the government specifications for low embodied carbon materials under the Inflation Reduction Act as guided by the EPA. For manufacturers, designers, and users of construction products who are deeply committed to sustainability, aligning with LEED offers several key benefits. Number 1, industry relevance. LEED is the most widely recognized green building rating system in the world. By using its framework, we're able to speak a shared language with architects, contractors, customers, and other stakeholders across the industry, ensuring consistency and clarity in our sustainability efforts. Number 2, comprehensive framework. LEED addresses every major facet of environmental sustainability, from site selection and water use to energy performance and indoor environmental quality. This holistic approach supports our goal of evaluating the full life cycle impacts of our products in the built environment. Number 3, continuous improvement. LEED isn't static. It evolves continuously to incorporate emerging best practices and cutting-edge research. By aligning with LEED, we show that we're committed to staying ahead of the curve and ensuring our products meet the highest and most current sustainability standards. Number 4, credibility and trust. A LEED certification is a respected mark of excellence in sustainable building, and by grounding our approach in LEED, we enhance our credibility and build trust with clients who prioritize environmental responsibility. And 5th, market advantage. As demand for green construction solutions increases, aligning with LEED helps position ourselves as market leaders. This can strengthen our brands, attract new business, and sharpen our competitive edge. In short, using LEED as the basis for today's sustainability conversation offers a host of advantages, from increased industry alignment to stronger marketing positioning. Embracing this framework is not only a practical step, it's a strategic one that enforces our leadership in sustainability. To earn LEED certification, a construction project has to meet specific criteria in a number of key areas. These are called credit categories, and they include things like integrative process, location and transportation, sustainable sites, water efficiency, energy and atmosphere, materials and resources, indoor environmental quality, innovation, and regional priority. Each of these categories focuses on different parts of sustainable design, construction, and operation. Now, while it's true that as a manufacturer of cold form steel framing, our products mainly support credits in the materials and resources and indoor environmental quality categories, there's a strong case for why we should take a broader view of sustainability. Instead of just focusing on the documentation like EPDs and HPDs that our customers are asking for, we should think about adopting LEED principles across our own facilities and offices as well. Here are some key reasons why adopting LEED principles across our operations as building product manufacturers makes sense. First and foremost, it helps reduce embodied carbon. By making our own facilities and operations more sustainable, we can significantly cut down on the embodied carbon of our products. This can be done through better manufacturing practices, using less energy, adopting renewable energy sources, and cutting waste. Embodied carbon is becoming an increasingly important metric for environmentally conscious customers. So by reducing the carbon footprint of our products, we make them more appealing and competitive in the market. Second, it positions us as sustainability leaders. Taking this holistic approach to LEED shows that we're committed to sustainability at every level, not just in the products we make. It reflects our responsibility to environmental practices throughout the entire value chain, from manufacturing to office operations. This kind of leadership strengthens our brand, boosts our reputation, and builds trust with customers and stakeholders who value broad sustainability efforts. Third, it brings operational efficiency. Implementing LEED strategies in our facilities and offices can result in meaningful cost savings. We're talking about lower energy and water bills, reduced waste disposal costs, and even improved productivity from workers, thanks to healthier, more comfortable working environments. These savings not only help the environment, but they boost our financial performance, making us a more sustainable and financially stable business. Finally, it supports employee well-being. Creating a work environment that's in line with LEED standards improves employee health and happiness. This includes things like better indoor air quality, access to natural light and views, and comfortable temperatures. A workplace that promotes health and comfort leads to higher employee satisfaction, which leads to increased productivity and better retention rates. Now let's shift back to the product level and take a closer look at how low embodied carbon, or LEC, steel framing can contribute to LEED certification for our customers. Steel framing can contribute to several LEED credits, but today we'll focus on the key credits where LEC steel has a direct impact. Building Life Cycle Impact Reduction Credit. Cold form steel framing can contribute to option 1, and for option 2, the whole building life cycle assessment, having an LEC EPD, or Environmental Product Declaration, for your products will play a critical role in completing the LCA calculations. This can significantly help reduce the building's overall footprint. Second, the Environmental Product Declarations credit. This encourages the use of products and materials that have life cycle data available and those with environmentally, economically, and socially preferable impacts. It rewards project teams for selecting products from manufacturers who have verified improved environmental life cycle impacts. This is the biggest credit that's related to low embodied carbon steel framing, so it's definitely one to pay attention to. Option 1 is the Environmental Product Declaration. That can earn up to 1 point. What that requires is the use of at least 20 different permanently installed products from at least 5 different manufacturers that meet one of the disclosure criteria, which is products with a critically reviewed LCA or an internally reviewed product-specific Type 3 EPD, or an industry-wide Type 3 EPD count as 1 product. Products with third-party certified product-specific Type 3 EPDs, they count as 1.5 products. So if all your products have third-party certified EPDs, you only need 14 products rather than 20 to earn this LEED point. And option 2 is embodied carbon or LCA optimization credit. It's also worth up to 1 point. And for this option, at least 5 permanently installed products from at least 3 different manufacturers must have an embodied carbon optimization report or action plan separate from the LCA or EPD. The value of various reports contributes to the required product count, ranging from half a product to 2 products, depending on the level of carbon reduction. This is an attractive option for manufacturers that have low embodied carbon EPDs, as it allows lead teams to earn an extra point with as few as 5 optimization reports, compared to needing 20 standard EPDs. Additionally, the point for option 2 can be earned alongside the point for option 1. Now we're going to talk about the sourcing of raw materials credit and how LEC, or low embodied carbon steel, fits in. This credit rewards responsible sourcing and extraction practices. Points are awarded based on the percentage of building product costs that meet responsible sourcing criteria. Notably, products that meet recycled content criteria are valued at 100% of their cost. And since low embodied carbon steel generally does have a higher recycled content percentage, it can significantly boost your project's performance in this credit category. Moving on to the final 2 materials and resources categories where steel framing can make an impact, let's look at material ingredients and construction and demolition waste management. First, material ingredients. Steel framing can contribute to both the material ingredient reporting option and optimization credit. This is because steel manufacturers often provide transparency around the ingredients used in their products, making it easier to meet the requirements for these credits. Construction and demolition waste management. Steel framing really stands out in this category because steel has inherent recyclability. With a strong national recycling infrastructure, steel is easily diverted from landfills. And on top of that, ordering cut-to-length materials and using prefabricated components on site can significantly reduce your construction waste, making steel framing a sustainable choice in this area as well. We'll briefly take a look here at indoor environmental quality and how steel framing contributes to that. Acoustic performance. Steel framing, along with acoustical accessories, helps meet the requirements for minimizing exterior noise and controlling sound transmission, particularly in spaces like classrooms. Low emitting materials. Steel framing can contribute to this credit. While LEED doesn't technically classify it as inherently non-emitting, it's often treated as such. And if needed, volatile organic compound emissions testing can confirm that steel is low emitting. And acoustic performance again. Steel framing and related accessories also help meet standards for background noise, sound transmission, and reverberation time. This contributes to a better indoor environment, supporting occupant well-being and productivity. Let's move on now to government specifications for low embodied carbon steel. Government procurement policies at the federal, state, and local levels are commonly referred to as buy clean policies. I do want to quickly acknowledge that recent executive orders from the new administration have rescinded support for federal buy clean programs. I have reached out to some well-connected consultants on this, and generally the consensus is that we don't yet know what this means or how it will affect these programs. What we do know is that these programs are on hold while legal reviews take place, and the general belief is that most state and local level programs will remain affected and continue to move on forward. Now, moving on to buy clean policies. They are transforming the construction industry by encouraging the use of low embodied carbon materials in government funded projects. These policies require manufacturers to provide environmental product declarations, which I've mentioned previously as EPDs. These disclose the environmental impacts of their products, including their global warming potential, or GWP. By setting GWP limits or offering incentives to do so, buy clean policies push the construction industry to prioritize sustainability materials, driving a shift toward a more environmentally responsible built environment. Just a quick reminder throughout this presentation, for the purposes of our presentation, the terms GWP and embodied carbon are essentially referring to the same thing. So how common are buy clean policies right now? It's always changing, but these policies have been gaining real momentum across the US since California passed the first buy clean legislation in 2017. And what you're looking at here is a map from the Carbon Leadership Forum. And while it's from April 2024 as a snapshot of state programs that have either been proposed or already adopted, the growing trend is still visible at all levels, federal, state, and local, as more governments realize the impact they can have by using their purchasing power to promote low embodied carbon materials and more sustainable construction. Let's zoom in a bit on this and take a more detailed look at these policies using Figure 4 here from the Carbon Leadership Forum. This chart lays out the current implementation status and timelines for buy clean policies at the federal, state, and local levels across the US. You can see with the key at the bottom, I know it's a little tough to see because it's kind of small print, but you can see there when each policy was passed or enacted, how long it took to fully develop, and when actual limits on materials like GWP thresholds were put into place. So far, there are 8 states with active buy clean policies: California, Colorado, New York, Oregon, New Jersey, Maryland, Minnesota, and Washington. On the local level, there are at least 2 notable programs, one in Portland, Oregon, and the other through the Port Authority of New York and New Jersey. At the federal level, requirements have been established by the GSA, or General Services Administration, and the Federal Highway Administration, as well as FEMA, all funded through the Inflation Reduction Act. These are supported by the Federal Buy Clean Task Force, which is working to develop environmental embodied carbon policy recommendations alongside the EPA's interim determination for low carbon materials. Just to revisit the recent executive orders, while they may affect future federal funding, they're not expected to impact state or local programs, and those efforts will continue, likely moving forward independently. So that's a lot of policies and a lot of information to take in. And you're probably wondering, what does all this mean for cold form steel framing? And more specifically, which of these policies do I actually need to keep my eye on? And the answer is the U.S. General Services Administration, or GSA. And under the Inflation Reduction Act, or the IRA, that was passed in 2022, the GSA was given $3.375 billion to invest in reducing carbon emissions in federal buildings and to help spark innovation. Out of that, $2.15 billion is specifically set aside for buying and installing construction materials that have substantially lower embodied greenhouse gas emissions as determined by the EPA. Now, beyond the massive amount of funding, why should this matter to the steel framing industry? Well, it's because this is the first buy clean policy that actually sets embodied carbon limits specifically for cold form steel framing. If you look at the bottom of the GSA chart that I have here circled in red, you'll see those limits are clearly listed. These apply to the global warming potential values in your EPDs. None of the other Buy Clean policies we talked about earlier had done this yet, but now that the GSA has led the way, we are starting to see other state and local programs considering the same limits. So this will likely become more widespread in the future. As for the recent executive orders pulling back federal support for Buy Clean, right now the understanding is that most of the funding for these GSA projects has already been dispersed. So the current projects with low embodied carbon requirements are still moving forward, and we're seeing that in the market. That said, we don't know yet what impact this will have on future low embodied carbon requirements for GSA projects. It definitely is something to watch closely, though. Now that we've built a solid understanding of how LEED shapes our approach to sustainability, and we've taken a look at the current landscape of government policies, let's shift gears and dive into a more specific piece of the sustainable construction puzzle, embodied carbon. We'll break down exactly what embodied carbon is, why it matters, and how it has a major influence on a building's total environmental impact. So let's get to the core of what embodied carbon really means. In simple terms, embodied carbon refers to all of the greenhouse gas emissions that are generated throughout the entire life cycle of building materials. That includes everything from the extraction of raw materials to manufacturing, transportation, installation, maintenance, and finally disposal or end of life. It's important to understand how this differs from operational carbon, which only looks at the emissions that are produced during the use phase of a building, like energy for heating, cooling, and lighting. Embodied carbon zooms out from that and takes a much broader view, which accounts for the full environmental impact of the materials that actually make up the building. Before we dive any deeper, we're going to pause for a quick informal poll question, and this is different from the one that Kayla mentioned. So no pressure to get the right answer here. This is just a way to capture your initial thoughts on it, and we'll circle back to it later once we've explored the topic more thoroughly. Feel free to drop your answer in the chat or Q&A window on this one. So considering the definitions we've just covered, which type of carbon do you think contributes more to the total end-of-life carbon content of the built environment? A, embodied carbon, B, operational carbon, or C, they contribute roughly equally. And I'll give you a minute to drop those answers in the chat or in the Q&A, whichever you prefer. Okay, we'll circle back to that in a moment and move on now, though. Now that we've got a solid understanding of what embodied carbon is and the processes it includes, we'll talk about how it's actually measured. So the main tool we use is called a life cycle assessment, or LCA. I've mentioned this previously, and this is a standard method that looks at the environmental impacts of a product or a system across its entire life cycle, all the way from raw material extraction through to disposal. So to make the results meaningful and easy to compare, we use a metric called global warming potential, which I've also mentioned previously, abbreviated as GWP. It's typically measured in kilograms of carbon dioxide equivalent. So in simpler terms, GWP helps us compare the climate impact of different greenhouse gases by converting them into the equivalent amount of CO2. So regardless of the specific gas, you're able to understand and compare how much each one contributes to climate change using a common scale. All right, so we understand how embodied carbon is measured, but why does it matter so much? Let's zoom out even farther and look at the big picture. Take a look at this chart on the right from the Carbon Leadership Forum. It shows that building materials alone are responsible for about 7% of global greenhouse gas emissions. When you include infrastructure, that number climbs to 17%. And that's a major share, and it makes clear just how big a role embodied carbon plays in climate change. Now, one important thing to keep in mind is that this chart reflects emissions for just 1 year. It doesn't account for the entire life cycle of emissions across different sectors. We'll explore that a little bit more in the following slide. What really makes embodied carbon stand out is that much of it is upfront. It's released before the building is ever occupied or operational. And that means that the decisions that we make early in the design and construction processes, like which materials we choose, will have a huge impact. And because these emissions accumulate over time, the sooner we start reducing them, the more we can mitigate their long-term effects on the planet. It's a call to action for making smart, sustainable choices from the very beginning. Let's visualize how embodied carbon and operational carbon play out over the course of a building life cycle. And this goes back to the question that I asked earlier. So this graphic shows the different stages in a building's life cycle and breaks down where embodied and operational carbon emissions happen. The yellow color, which is the majority of this slide, represents embodied carbon, which includes emissions from raw material extraction, manufacturing, transportation to the construction site, the construction process itself, and the use phase. It even goes to end of life handling, including demolition, processing, and disposal of materials. On the other hand, the blue color represents operational carbon, which only accounts for the energy and resources consumed during the building's use phase. So think things like heating, cooling, and electricity during the operation phase. So as you can see from this graphic, embodied carbon is generated at various points all the way across the building's life cycle, long before the building is even operational. This visualization really drives home the point that when we're looking at a building's overall carbon footprint, it's really essential to consider embodied carbon as a significant factor in addition to the operational emissions. So now that we've explored the details of embodied carbon versus operational carbon and kind of showed the differences, let's circle back to that question I asked earlier and see if anyone's perspective has shifted or stayed the same. So again, the question is, considering the definitions that we've provided, which type of carbon do you think contributes more to the total end-of-life carbon content of the built environment? A, embodied carbon, B, operational carbon, or C, they contribute roughly equally. And feel free to let us know if your perspective has changed in the chat or Q&A, or reveal your answer now at this stage in the presentation. So more on this topic. The Carbon Leadership Forum published a study in 2024 that looked into the timing and magnitude of both operational and embodied emissions across 60 buildings in California. Now, for this study, in this graph, the orange bars represent embodied carbon and the blue bars represent operational carbon. The study revealed the following. It revealed that 81% of the total carbon footprint comes from embodied carbon over a 6-year life cycle. It revealed that 71% of the total carbon footprint comes from embodied carbon over a 21-year life cycle, and over a 60-year life cycle, 63% of the total carbon footprint comes from embodied carbon. Now, while commercial buildings can often have different lifespans, data suggests that they're often demolished around the 35-year mark due to things like functional obsolescence, economic pressures, and additionally, we know that cold form steel framing is likely to be replaced several times over the course of that building's lifespan. So with this in mind, it's safe to say that except for specific outlier circumstances, embodied carbon makes up a majority of the carbon footprint for a typical commercial building. And what this means is that in the short term, reducing embodied carbon is just as critical, if not more so, than reducing operational carbon. And this underscores the urgency of focusing on embodied carbon reductions as we plan for a sustainable built future. All right. Cold form steel framing offers a variety of benefits when it comes to reducing embodied carbon. So here's why it's a great choice for sustainable construction. It has high recycled content. It has a high percentage of recycled material, which reduces the carbon footprint right from the start. Also, due to lightweight nature, its lightweight properties reduce transportation emissions, making it more energy efficient to move around. Design flexibility. Cold form steel can be easily adapted to meet specific project needs, which reduces waste and enhancing material efficiency. And also potential for reuse and recyclability. At the end of its life cycle, cold form steel can be reused or recycled, contributing to a circular economy. So by strategically incorporating cold form steel framing, we can play a role in creating a more environmentally responsible built environment while helping reduce embodied carbon. Lastly, let's dive a little deeper into the definition of embodied carbon, and let's clarify the term embodied carbon equivalent, or CO2e. When we talk about embodied carbon, we're actually referring to the total greenhouse gas emissions emitted over a product's life cycle, not just carbon dioxide. That's why we use the term carbon dioxide equivalent, or CO2e, because it accounts for all greenhouse gases, including methane, nitrous oxide, and others, by converting them into their CO2 equivalent, or CO2e, based on their global warming potential. Each greenhouse gas has a different global warming potential factor, which compares its effect on climate change to CO2. So by converting all emissions into CO2e, we can make a standardized comparison of the overall climate impact of different products and processes. So even though we often refer to it as embodied carbon for simplicity's purposes, remember that this term actually represents the full spectrum of climate impact from all GHG emissions associated with a product's life cycle and not just CO2. Moving on to our third learning objective. So now that we've covered the importance of embodied carbon, let's dive into a key factor that affects it in steel, the production method. There are two main steelmaking processes, the electric arc furnace, or EAF, and the basic oxygen furnace, or BOF, and each has its own environmental impacts. Understanding how these methods differ is essential when choosing low-embodied carbon steel for your projects. Let's take a closer look at how these two steelmaking processes differ. This graphic from Charter Steel gives a simplified comparison of the EAF and BOF methods. The key difference here is the raw material used. You notice EAF relies mostly on scrap steel, while BOF primarily uses iron ore. Now, this matters because EAF, with its focus on recycled scrap steel, uses less energy and produces fewer greenhouse gases compared to BOF mills. On the other hand, BOF involves energy-heavy processes like coke ovens and blast furnaces, and that results in higher emissions. So in short, EAF skips those more emissions-intensive steps, and that leads to lower carbon footprints. We're going to take a closer look at the production process differences so you can kind of see the specific differences from start to finish. So the chart here is from the World Steel Association, and it outlines the 7 stages of steelmaking that occur before a steel framing manufacturer even gets their coil. So here's the breakdown. From left to right, we have number 1, input raw materials. Number 2, raw materials preparation. Number 3, iron making. Number 4, steel making. Number 5, semi-finished products. Number 6, hot rolled products. And then finally, finishing operations. And then, of course, stage 8 would be roll forming, which isn't shown on the chart. So the general path the steel takes before it reaches a roll forming plant looks something like this on this chart. The embodied carbon in the Steel Framing Industry Association, EPD, represents the greenhouse gas emissions associated with the entire upstream value chain up to this point. So this red outline I have here around the certain processes on this chart, that isolates the basic oxygen furnace steps, or BOF. So remember that the red outline here represents, it doesn't just represent BOF, it represents EAF and BOF processes. So in blue here, you'll see it's almost identical. Blue here is what you'll see in just the BOF processes. So it still pretty much includes all of the steps, only excluding the EAF furnace. Now we'll take a look at the process if we isolate the electric arc furnace steps, remembering that the red outline represents combined EAF and BOF. So with the assumption of 100% scrap steel in the EAF process, it bypasses the first 3 high emission steps completely, making its overall embodied carbon much lower than the BOF process, which does have to go through those first 3 really intensive emissive steps. The choice between EAF and BOF steelmaking really matters from an environmental standpoint, as we've seen. EAF offers a cleaner, more sustainable option, producing steel with a much lower carbon footprint and supporting the circular economy. By prioritizing the use of EAF steel, we can take a meaningful step toward reducing our environmental impact and promoting a more sustainable built environment. So here's a great question that we often get. If EAF sourced steel is so sustainable, then why don't cold form steel framing manufacturers only use EAF steel? And there's a very good reason that we need both of them. Actually, there's several reasons, so I'll break it down. Number one is resilient supply chain. So by sourcing steel from both EAF and BOF mills, we create a more resilient supply chain. This helps us avoid disruptions and ensures we always have a reliable and consistent supply of steel no matter what challenges arise. Number two is mitigation of price volatility. If we were to rely solely on EAF mills, that could lead to supply shortages, which could definitely drive up prices and cause delays. So a mix of EAF and BOF sources helps balance out price fluctuations, and that ensures cost stability for our customers. Number three is market responsiveness. Having a mix of suppliers allows us to stay flexible and adaptable to changes in the market. We can quickly respond to shifts in demand, technological innovations, and industry trends, keeping us competitive and proactive. Number four, scrap imbalance and steel demand market. The availability of scrap steel just doesn't meet the total demand for new steel production in the US. So because of that, both EAF and BOF steelmaking are necessary to meet the total market needs of steel. And lastly, but maybe most importantly, is collaborative sustainability. Supporting sustainability across the entire industry is vital. By working with both EAF and BOF suppliers, we can help drive eco-friendly practices for them both across the whole industry. BOF mills are actively working on more sustainable methods like hydrogen direct reduction and carbon capture utilization and storage. We're excited to collaborate with them as these technologies continue to evolve. And in my opinion, it's just the most important one, as it really is the lowest hanging fruit to assist the BOF mills in their initiatives to become more eco-friendly. So we've covered a lot of important information, and now it's time to bring it all together. Let's dive into how you can implement these strategies in your own projects, as we'll now explore practical ways to integrate these sustainable choices into your designs and specifications. So let's kick things off by talking about low embodied carbon by design. And one great way to do that is by using equivalent or EQ non-structural framing members. EQ studs are a newer technology that's been developed to replace traditional non-structural studs, which are usually sized and shaped according to older prescriptive standards. Instead, EQ studs are made with thinner steel but have higher yield strength, so they still do the same job just as well. And what makes this important is that using less steel means a lower embodied carbon footprint, and that's exactly the kind of impact that we're aiming for here. So we'll break that down more in just a minute on EQ studs. Before we do that, I'm not going to get too deep in the weeds here, but I do want to highlight some important reference info when it comes to the code requirements for prescriptive specs on non-structural framing. So the International Building Code, or IBC, now references AISI S220 as the go-to standard for these requirements. But there's one key piece I want to call your attention to. Section A1.2.4. Okay. That section specifically says that the standard, quote, does not preclude the use of other approved materials, assemblies, structures, or designs of equivalent performance, end quote. In other words, there's flexibility built into it. So alternatives like EQ studs are fair game as long as performance is equivalent, which it is with EQ studs. So this naturally leads to the question, how is equivalent performance actually determined? Fortunately, the Steel Framing Industry Association, or SFIA, through its dedicated technical committee, has developed a comprehensive code compliance certification program. Section E of this program outlines the specific performance requirements and testing methods needed to meet the equivalent performance standard established by AISI S220. Importantly, this program also provides third-party certification of EQ studs, ensuring confidence and reliability. So we'll shift our focus back now to how EQ studs can play a crucial role in reducing embodied carbon in construction projects. As you can see in the spreadsheet, we've calculated the embodied carbon differences between traditional 25 gauge studs and 25 gauge EQ studs. It's important to remember throughout this that embodied carbon in steel framing is measured in metric tons of CO2 equivalent per metric ton of steel. And because EQ studs utilize higher strength steel, they can be manufactured with thinner gauges, resulting in less mass or fewer metric tons, and therefore lower carbon emissions, that is, lower embodied carbon. This example specifically highlights 25 gauge EQ studs, which are 15 mil. The key takeaway here is that by simply designing with 25 gauge EQ studs, you can achieve an embodied carbon reduction in your project steel framing by up to 12.7%. Now, this slide looks similar to the last one, but it is slightly different. So we're going to take a look at another example that further demonstrates the significant carbon savings potential of EQ studs. In this case, we're going to compare 20 gauge traditional studs with their 20 gauge EQ counterparts, often referred to as 18 mil studs. And as you can see, the potential for embodied carbon reduction here is even more dramatic. Again, by simply designing with 20 gauge EQ studs, you can achieve an impressive reduction of up to 35.7% in your project's embodied carbon for steel framing. And that's a substantial reduction that can significantly contribute to a project's overall sustainability goals. So let's quickly recap the big takeaways from our conversation on EQ studs and why they matter for embodied carbon. First off, EQ or equivalent studs are made with higher strength steel, which means they can be manufactured using thinner, lighter gauge material without sacrificing performance. That added efficiency in material use is where the embodied carbon savings really kick in. From the examples we looked at, those savings can be impressive. Using the 25 gauge EQ studs, we saw that it showed a potential of 12.7% reduction in embodied carbon. And with the 20 gauge EQ studs, we saw the number jump all the way up to 35.7%. So if you're looking to hit sustainability goals and lower your project's carbon footprint, EQ studs are a powerful tool to help make that happen. It's a very simple way to go green, simply put. As we start getting into the details of how and where to specify low embodied carbon steel framing, I'm bringing back up this chart for the GSA IRA limits for low embodied carbon steel with the circled section at the bottom of cold form and galvanized steel. It's important to recognize that we're still operating in a space largely without officially adopted code reference standards for this. But that doesn't mean that we're flying blind, and thanks to this standard by the GSA, these limits can be used as a benchmark. So these thresholds are based on SFIA industry average data pulled from the widely recognized EC3 calculator and were carefully reviewed by the EPA and experts across the entire field. So if you look at the chart again, the GSA considers steel framing that performs better than 2,228 kilograms of CO2e per metric ton of steel to fall within the top 20% category. That's why we recommend using this number as your working definition of LEC steel framing, because it's a solid and credible reference point to start building your specs around. Now that we've defined what qualifies as low embodied carbon steel framing, the next big question is, how do you actually verify that the steel you're specifying meets those criteria? And that's where environmental product declarations, or EPDs, come into the picture. I mentioned those towards the beginning of this presentation, and now they're back. So what EPDs do is they give you a standardized way to see a product's environmental impact across its entire life cycle. For our purposes, not just any EPD will do, we need to look at specifically LEC EPDs, or low embodied carbon ones. LEC EPDs go a step further than typical EPDs. They come with stricter sourcing requirements, often requiring steel from electric arc furnace or EAF mills, which, as we discussed previously, generally do have a lower carbon footprint. And here's the takeaway. Specifying LECEPs alone can cut embodied carbon by over 30% for steel framing. But when you combine that with the savings from using EQ studs, you're looking at a much larger overall impact, significantly lowering the carbon footprint of your project. And this combined strategy is a powerful move toward making your construction practices more sustainable. So as we wrap up the conversation around specifying low embodied carbon cold form steel framing, let's talk about the all important question. Where do these requirements actually go in your project documents? And there's a few options, but we suggest focusing on three key spec sections. First is 018113, Sustainable Design Requirements. This is the most logical place for overarching sustainability goals, including your LEC framing requirements, and it sets the tone early and signals your project's priorities in the specifications. Next, we have 054000. That's cold form metal framing. So this section actually directly addresses cold form steel. So placing your LEC criteria here ensures that the team that's responsible for structural framing does see and follow them. Lastly, we recommend 092216, which is non-structural metal framing. If your LEC goals are specific to non-structural framing, this is the right spot to include them. It reinforces the requirement for the trades actually installing these materials. And one last tip, remember those GSA IRA limits that I've covered a couple of times? Reference those when setting your benchmarks as a tip. These thresholds are already vetted, they're understood across the industry, and that helps streamline coordination and it'll avoid unnecessary confusion in the future. As we bring today's presentation to a close, let's quickly recap a few points that can help guide your decisions when it comes to cold form steel framing and sustainability. First off, cold form steel framing, especially when you combine it with EQ studs and low embodied carbon steel, can play a big role in supporting LEED certification and meeting LEC targets. Second, don't underestimate the impact of embodied carbon. Addressing it early in the design process is one of the most effective ways to reduce a building's overall environmental footprint. Third, be mindful of how your steel is being made. Choosing EAF source steel can significantly lower embodied carbon, but it is also important to recognize the continued role of BOF mills that they're playing in maintaining a stable, responsive supply chain and how the entire industry is working together toward more sustainable practices. And finally, when you bring all of it together, EQ studs, LEC steel, smart specifying, you're not just reducing carbon, you're helping shape a more sustainable future for the built environment for everyone. That concludes today's continuing education course, and I want to thank you all for your time in joining me today. I know that Adam has been answering some of your questions in the chat along the way, but we can now open up the session for questions or discussion points if time allows. So, Kayla, did you have any questions set aside, or if Adam hadn't gotten to any?
I'm not seeing any unanswered questions right now, Adam. Is there any ones that you wanted to bring back up or?
Yeah, I didn't see any, you did a really good job covering all that. So you must have answered everybody's question 100%, but we got a little time if people have anything unanswered, they want to pop in there.
Yeah,
Yeah.
absolutely. And if it's something that we aren't able to answer, we'll be able to send you follow-up answers via email after the presentation concludes, and we're able to obtain a more proper answer.
We got one. How does the use of LEC steel stud structural systems compare with other structural systems?
So that's a tough one because a lot of the embodied carbon measurements for various structural systems can differ from structural system type to type. So there haven't been too many studies, at least that we're aware of, that are specific enough in comparing the different structural systems. But we do know that LEC steel stud structural systems do go a long way toward making steel framing competitive.
Hey, James, you could scroll back up to that GSA chart.
Yep.
If I think maybe it's not exactly what he's asking, or what Stephanie's asking.
Yeah, so we can go back to the GSA limits for low embodied carbon steel, and you can see that the limits for low embodied carbon steel are still quite above the other product categories, but it's definitely a significant reduction.
Yeah, so a little bit more on that. You'll see, let's say, rebar, hollow structural sections, sections, electric arc furnace. So cold form steel comes from the coils, which have more processing requirements than, say, structural steel. But those aren't really direct competitors of us, right? Because you're going to put up a structural steel red iron building, but then you're also going to use cold form steel in frame for the walls. So it's not really a one-to-one comparison against these other structural systems, but you will see that the various structural elements in steel all do have very varying different levels of their embodied carbon in this chart. So hopefully that helps answer your question, Stephanie.
Yeah, that's correct. And that was exactly what I was going to mention, is the question she just followed up with, which compared to wood systems. And that's where my initial answer really applies, in that it's there hasn't been too many studies that have been able to make the effects totally equivalent. There's different metrics that both sides will use to claim superiority. And all we can do at this point is try to focus on reducing our embodied carbon impact in the steel industry. And there's various ways that steel can be advantageous, such as its inherent recyclability. But overall, the different measurements that they use in their studies are different. So it's hard to have an equivalent study.
Yeah, a little bit more on that, James, is wood measures their embodied carbon in cubic meters, right? And we measure it in metric tons of CO2 per metric ton of steel. So the measurements are nearly impossible to compare at this point, but obviously as an industry in steel, we'd like to get there so we can really have a more accurate idea of, how close they are.
Correct. So again, we don't have quite an accurate representation of how close we are. We do know that non-low embodied carbon steel is not going to be nearly as competitive with wood systems, but that low embodied carbon steel is a big step forward toward that. So, yeah, I wish I could say more about how we're equivalent or not, but I do know that low embodied carbon steel is going to be much closer.
Well, great point in the chat by somebody. Says it doesn't burn as easily. So yeah, that is one thing. In fires, the steel is not going to burn and readmit the carbon back into the atmosphere like wood will. So that's another thing about the life cycle assessments. There's a lot of variables that are really hard to account for when you're comparing them. So.
Right. Yep. And again, I'll point out too, the inherent recyclability of steel framing is a big competitive edge that we have in our industry.
Looks like that's about it, sir.
Great.
I think so.
Well, thank you, James and Adam. That was really thorough. I think everybody appreciated it. I just want to point out one more time before we make any final notes today that if you weren't here earlier, I mentioned that if you filled out the poll, we will be sending you an email connecting you with James and Adam and their team. So we encourage you to respond to that email directly if you'd like to engage with them. You can also log into Acelab and respond to those conversations there. But definitely a great way to get any further maybe project-specific questions answered. That's a great way to do that. So we definitely appreciate your participation there. But that's, I think, everything for today. James, did you want to make any final comments before we wrap it up today?
I just want to thank everyone for their time, and yeah, feel free to reach out to me and Adam. And this is a topic that we talk about a lot, and we look into a lot, and it's something that we really enjoy discussing with people and getting people on board and educated. So feel free to reach out to us, and we encourage it.
Thank you so much. All right. Have a great day, everyone.